Hello, I'm Terry Maloney, Senior Vice President and General Manager of American Isuzu Motors. Recently I sent you a letter regarding Consumers Union's news release about the safety of our 1995 and 1996 Troopers. In that letter, I promised an extensive review of our own test data as well as that of Consumers Union. The most important news is that our investigation and analysis has confirmed that the Trooper is a safe and reliable vehicle. In test after test, both here and in Japan, we put the Trooper through a battery of severe avoidance maneuvers in all sorts of driving conditions. And in each instance, the Trooper displayed exceptional control and stability for a sports utility vehicle. So why were Consumers Union's findings different from our own? The following video footage, taken from our own test data, as well as that of an independent third party, will help answer that question.
Immediately following the Consumer Reports press release in August, American Isuzu Motors, in concert with Isuzu Japan, undertook a comprehensive investigation of all the handling and stability testing conducted on the current model Trooper. Isuzu also commissioned a third-party team of independent engineers to retest the Trooper and review the Consumers Union's findings. Why all of this testing and research? To fully understand the situation and determine what action should be taken. During the development of the Trooper, Isuzu rigorously and extensively tested the vehicle at Isuzu's proving grounds in Fujisawa and Hokkaido, Japan. The following footage demonstrates some of the tests conducted on the 95 and 96 Trooper. In one of the tests, the Trooper was put through multiple runs on a high-speed slalom course at 70 miles per hour. Although there is some body lean, which is to be expected with this kind of maneuver, the Trooper handles it capably. Also at 70 miles per hour, the Trooper is seen successfully handling a severe lane change test. Next, the Trooper was subjected to slalom tests at speeds of 45 miles per hour. Again, the Trooper's handling is stable and responsive. Finally, the Trooper is seen managing a slalom course at 50 miles per hour. The Trooper was also tested on rough road conditions, which are meant to evaluate the handling aspects of the Trooper in an off-road situation. Although Isuzu had already performed exhaustive tests on the Trooper in Japan, they commissioned additional testing by independent experts. Car Engineering, a company specializing in automotive testing and evaluation, put the Trooper through its own testing regimen. Like Isuzu's tests, many of the tests performed by Car Engineering are based on scientific and generally accepted test protocols, developed by engineering organizations like the International Organization for Standardization and the Society of Automotive Engineers. These tests are used by automotive engineers around the world to evaluate the handling capabilities and performance limits of vehicles. One such test is the high-speed slalom, which was conducted on the Trooper as seen here at 50 miles per hour. The severe lane change at speeds of 55 miles per hour. And the limit turn in a circle, which shows the vehicle handling high lateral forces at the limits of tire traction. The Trooper passed each of these tests without difficulty, remaining stable and in control. Finally, Car Engineering reviewed the videotape supplied by the Consumers Union to better understand their test and the reasons for their results. The first analysis examined the steering input of all the vehicles tested. By freeze-framing the path of each vehicle as it enters the course and then recreating the angle of the wheels, the engineers can determine the degree of driver input on the steering wheel of the vehicle. In other words, how much the steering wheel is turned to affect the angle of the wheels. By freeze-framing the Trooper as it enters the course, we can see, by recreating the angle of the wheels, that the steering input to the left is 450 degrees, which translates to 1¼ full turns of the steering wheel. At the obstacle cone in the middle of the course, the Trooper was turned back to center and then an additional 540 degrees to the right. That translates to 990 degrees of total right steering input, or 2 3/4 turns of the steering wheel. Next, the Toyota 4Runner was analyzed. The left steering input is 180 degrees, or 1/2 turn of the steering wheel upon entering the course, versus the Trooper's 1 1/4 turns of the steering wheel. As the 4Runner continues through the course, it is turned back to center and then an additional 270 degrees to the right at the next obstacle cone. That equates to 450 degrees of total right steering input, versus the more than double 990 degrees of total right steering input for the Trooper. Next, the Chevy Tahoe was driven through the course. As the video shows, it was turned 270 degrees to the left at the entrance to the course, then back to center and an additional 450 degrees to the right at the midpoint, for a total right steering input of 720 degrees, or 2 full turns of the steering wheel. Finally, the Nissan Pathfinder enters the course. The Pathfinder is turned 270 degrees to the left at the first set of cones, as the Pathfinder continues on, it is turned back to center, then turned 360 degrees to the right at the middle cone. This equates to a total right steering input of 630 degrees, or 1 3/4 turns of the steering wheel. This analysis shows that there was a significant difference in the steering input applied to the Trooper as compared to the other vehicles tested. Next, the independent engineers at Car Engineering analyzed the path along which each vehicle was driven through the course, again, to evaluate the driving consistency between vehicles. First, the Trooper was compared to the 4Runner. At the entrance of the course, the vehicles are lined up differently in relation to the left cone. Where the 4Runner hits the left cone, the Trooper doesn't touch it. This test is analogous to a slalom skier racing downhill between the gates. The key to having the best run is to eclipse the gates as close as possible. Similarly, the closer the vehicle is to the cones, the straighter the course becomes, making it easier to negotiate it successfully. At the midpoint of the course, however, the Trooper is wide of the right cone where the 4Runner is very close to it. This comparison was also done with the Chevy Tahoe. Again, the Tahoe is closer to the left cone on the first turn and also tighter to the right cone on the second turn. Finally, the comparison was done with the Nissan Pathfinder. Once again, the Pathfinder is closer to the left cone on entering the course, and also closer to the right cone at the midpoint of the course. This shows that the Trooper was driven differently through the same course compared with the other 3 vehicles tested. In 1992, Consumers Union described this short course test in its magazine. In order to determine whether this type of test should be added to their already extensive testing regimen, the Isuzu engineers recreated the test in 1993 and ran the prototype of the 1995 Trooper through the course. The vehicle passed without difficulty. Isuzu's engineers concluded, however, that the Consumers Union test was unreliable because it is too easy for the driver of the vehicle to knowingly or unknowingly influence the outcome of the test by the way he chooses to drive the vehicle through the test course. In 1988, the federal government, specifically the National Highway Traffic Safety Administration, also concluded that this test was not reliable because it did not relate to real-world accident avoidance maneuvers and the test could be manipulated by the driver. There appears to have been sufficient latitude to allow a driver, either knowingly or unknowingly, to influence the testing without readily being detected by the available instrumentation. The test procedures do not have a scientific basis and cannot be linked to real-world crash avoidance needs or actual crash data. Using the same procedures, probably any light utility vehicle could be made to roll over under the right conditions and driver input. Since the outcome of the test is overly dependent on the driver's input on the vehicle, this test has been rejected by the federal government, the British government, and Isuzu's engineers as unreliable. Recognizing that the Trooper was driven differently through the course is key to understanding why the Trooper handled the way it did. The performance capabilities and limits of all vehicles must be measured against what ordinary drivers typically experience and demand in normal driving, as well as emergencies. An ordinary driver traveling down a road or highway maintaining the speed limit will normally experience no more than about 0.1 to 0.2 lateral Gs. A lateral G is the gravitational force that pushes on a car from the side, like the force that causes a coffee cup to slide on the dashboard when you round a corner. These are the side forces that you may have felt when exiting a freeway off-ramp or driving through a curve. It is not enough to design for the normal. Isuzu designs for the abnormal as well. Published engineering studies tell us what ordinary drivers typically do in an emergency. According to those studies, an ordinary driver will not voluntarily expose himself or his vehicle to more than 0.4 to 0.45 lateral Gs in an emergency situation. This means that the driver will not voluntarily steer the vehicle so as to generate more than 0.45 lateral Gs. A driver can also experience lateral Gs involuntarily if, for example, the vehicle is hit by another car or driven into a ditch. All of this is well known and well accepted by automotive engineers. Isuzu has designed the Trooper and all of their vehicles with a built-in margin of safety. For example, the Trooper is designed to remain stable and controllable at lateral Gs in excess of 0.75 Gs. Generally speaking, all SUVs, light pickups, and minivans have been designed with the same level of performance in this respect. For a frame of reference, most high-performance sports cars are controllable to around 1.0 lateral Gs. In other words, the Trooper can and does remain stable at lateral G loads, which are well in excess of what ordinary drivers typically experience or demand, even in emergencies. By tracking the path of each of the vehicles tested, we can better understand how the G-forces affected their handling. The blue line represents a path similar to the path along which the 4Runner, the Chevy Tahoe, and the Pathfinder were driven. As you'll recall, these vehicles were driven closer to the cones with less steering input than the Trooper. The red line represents the path of the Trooper. As shown previously, the steering input of the Trooper was far greater and the path the Trooper was driven was less direct. The red path along which the Trooper was driven generates a peak 1.6 lateral Gs at the center cone, where the driver lost control. By comparison, the path followed by the other vehicles generates peak lateral Gs of only 0.7, which is well within the Trooper's performance capabilities. Going back to our chart, which shows lateral G levels that different vehicles can withstand, the 1.6 lateral Gs far exceeds the performance limits of all SUVs and even most high-performance sports cars. The overall effect of the different steering input and different driving path taken for the Trooper was to generate a path resulting in more than 2 times the peak lateral G-forces for the Trooper than the other vehicles tested. Even though this video has shown the Trooper performing several extreme maneuvers, sports utility vehicles do not handle like ordinary passenger or sports cars. Sports utility vehicles have higher ground clearance to permit them to be used both on-road and off-road, and in rough terrain where ordinary passenger cars will not go. Higher ground clearance and ride height also provide better visibility for the driver so you can see and anticipate problems sooner. As with any vehicle, caution and common sense should be used when driving. Where possible, avoid making sharp turns or abrupt maneuvers. Familiarize yourself with the Trooper's handling and stability characteristics by reading the Driving Tips section of the Owner's Manual. The Owner's Manual supplement entitled Driving Your Four-Wheel Drive Vehicle, and the label on the driver's side sun visor.
From all the data that we have reviewed, our belief in the Isuzu Trooper has never been stronger. The Trooper is a safe vehicle. Thank you for taking your valuable time to review this important information, and thank you for your continued support of the Isuzu Trooper.